So, a very good morning, everyone. So, you can see as the question number 2 of exercise 1.1 is a very interesting question and easy questions. Show that the relation R in the set R, this R represent relation and this R, this capital means bold R, the bold R represent the real number, set of real number, okay, of the real number defined as, the relation is defined in this way that R is equal to A comma B. What is A? A is the element of codomain, domain, and also element of codomain. Means the relation is defined from R to R, from R to R, from R to R. We can take any real number to another real number. The relation is defined in this way, such that the value of A is always less than B square. Is always less than B. So A is the element of the first set and B is the element of second set. If I take 2, so obviously what is the B square? B square is 4. So 2 comma 4 is also exist in this. 2 comma 4 is also exist in this relation, right? Because obviously 2 is less than 4. Okay, so this so 2 comma 4 is also exist in this relation. But we have to prove what? That this relation is neither reflexive nor symmetric nor transitive. These are our question. We have to prove that they are not any of them. So what can you do is that? So we have to use such example. We have to find such example through using our common sense that it should not be reflexive. But the question arises, what is reflexive? Reflexive means what? When A comma A and same thing comma same thing should exist in this relation, then only it is called as reflexive, right? For example, 2 comma 2 is also exist in this relation, because if you take 2, you can take 2 from B also, because obviously B square is if I take 2 here, I can take 2 here also. Why? You can see, because what is the square of 2? Square root is 4. Okay, clear? So 4 is also less than what? 2. So this is exists, but we have to find such example which is not existing in it. So now example, now as it is a real number, we can take any value. We can take any fractional number, we can take any decimal number, we can take anything whatever we wanted, right? There is no any restriction. So we will take such example which does not suit in this category. So let us take let 1.2 comma 1.2 belong to the relation. Okay, 1.2 or 1.2 belong to is not belong to the relation, because 1.2 is not less than or equal to 1.2 square. You can see the value. Easily we have proved it, right? Because if I take half, because half is also belong to the real number, set of real number. So what happened? Can I say half comma half belong to the relation? Definitely not, because relation is defined in such a way that the A should be less than or equal to B square. Whatever B you take, it should be less than B. So I have taken half comma half. So half comma half is not belong to relation, because what? Half comma half, A is this one and B is this one. So if I take A, can you say A is less than half square? Half square means what? Half square means what? Half square means 1 by 4. And we know that this is very small than this. So what? This relation, this definition is not eligible in this case. This definition is not eligible in this case. Therefore we can say that relation is not reflexive. Relation is not reflexive. I hope the reflexive part is clear. It's very interesting. Reflexive part is clear. Now let us solve the next part, that is your symmetric part. Very easy, symmetric part. It is, I am proving the reflexive part here. Reflexive part here. Now let us go on solving the symmetric part here. It's going to be very simple. Symmetric. Symmetric means what? Symmetric means if A comma B belong to the relation and B comma A, the reverse is also present in the relation, then we can say this relation is a symmetric. So as the question says that we have to prove that it is not a relation. As we have to prove that it is not a relation. So what we have to consider? Now let us see the very interesting. So let us use a common tricks. So look here, I consider that 1 by 4 belong to 1 by 4 comma 1 by 2, these two things belong to the relation. How? Because this is belong to the relation, because half is 1 by 4 is A here and 1 by 2 is B here, because 1 by 4 is less than or equal to 1 by 2 square. Obviously, at least it will be equal, though it is not small, but it will be equal. So 1 by 4 is equal to 1 by 4. So that means we can say that 1 by 4 and 1 by 2 exist in the relation. It exists in the relation. But if you take reverse now, it is A or B. If you take the reverse, 1 by 2 and 1 by 4, does it exist in the relation? Let's see. It is not exist in the relation. Why? Because you can see why it is not exist in the relation, because 1 by 2 is not less or not equal to 1 by 4 square. 1 by 4 square, the result of 1 by 4 square is what? 1 by 2. Can you see that? The result of 1 by 4 square is what? Is 1 by 16. And 1 by 16 is not bigger than 1 by 2. Means it is very, very small to 1 by 2, and neither it is equal. So we can say that A comma B belong to the relation, but B comma A is not belong to the relation. So here what we can say, very simple. Here A comma B belong to relation, but B comma A is not belong to the relation, and hence we can say that it is not a symmetric also. So symmetry we have solved. It is not. Therefore, it is not symmetric. It is not symmetric. It is not symmetric. I hope that's pretty clear, my dear. Very interesting. Now let us go to the proof on transitive. Definitely this won't be transitive, because why? Because it is neither reflexive nor symmetric. So how it can be transitive? So let us prove it also through our examples. Now let us prove this transitive part here. It's going to be interesting now. Listen carefully. How to prove transitive? So let us consider example. Let us consider 3 comma minus 2n minus 1 belong to the relation. Come on. It is A, it is B, it is C. What is transitive? What is transitive? How to prove transitive? Let me remind you. So as if A comma B belong to the relation and B comma C belong to the relation, and then A comma C also belong to the relation, then we can say the relation is transitive. Remember, A B belong to the relation, B C belong to the relation, and A C also belong to the relation. So we can clearly say that the function or the relation is a transitive in this case. So let us go on solving here. So we can clearly say that here that 3 comma 2 belong to the relation. Why? As you can see that 3 is less than or equal to minus 2 square. Minus 2 square gives a positive result. So 3 is less than or equal to 4. It is true. Okay, then that is why it exists in the relation. Now I can take B, C also exists in the relation. Now look here. Also we can say that. Also we can write that minus 2 comma minus 1 is also belong to the relation. As you can see, as minus 2 is less than or equal to minus 1 ka square. Very nice. So you can see, very interesting. So because minus 2 is obviously less than 2, 1 is minus 1 square is minus 1. It is also true. But if you take A and C, this is the example I have taken from my side. You can take any example from you. Means ultimately we have to prove it is transitive. So for proving it is not transitive, it is upon you. It is no any fixed rule. There is no any fixed rule that you have to consider this only. You can take any other example, whatever you favor, whatever you like to do so. So now let us consider A and C. A and C, that means what? 3 comma minus 1. So this is not belong to the relation. A comma C is not belong to the relation. You can see why. As you can see, 3 is not less than or equal to minus 1 ka square. Because the result of minus 1 square is 1. Because the result of minus 1 square is give you 1. So 3 is not less than 1. So which is not true. That is true. Therefore we found that here I can say that A comma B, what is A here? 3 comma minus 2 belong to the relation, and belong to the relation, and B comma C is also belong to the relation, but there is one condition, but A comma C is not belong to the relation. So we can say that this is not a transitive. This relation is not a transitive. Therefore, the relation is not transitive. Therefore, the relation is not transitive. I hope it is pretty clear to every one of you here. Very interesting. So I am going to give one-on-one video. Now let us solve this question. Question number 3 of the exercise 1.1. So it is nice question, interesting, easy, simple question. So check whether the relation R defined in the set 1, 2, 3, 4, 5, 6 as R is defined as like that A comma B, where A is equal to A plus 1. So that means what? The relation is given from A, or there is one set to another set, and both are the same set. Let us consider A set and A set, and the elements on the sets are 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6 are there. So how is the relation defined? Where B is equal to A plus 1. B is equal to A plus 1. B is equal to A plus 1. That means if B is equal to A plus 1, then A is equal to B minus 1. If I take 1, I will get 0. There is no 0 in this case. So I cannot take A. Now next is what? I can take 2 comma. I can take 2 comma. Solution. So I can take A equal to B minus 1. B minus 1. If I take 2, I have to take 1. B minus 1. Clear? A equal to B minus 1. If I take B 2, so 2 minus 1 is 1. Clear? Same thing. If I take B3, already is given B equal to A plus 1. So A plus 1. And if I take here 2, so 2 plus 1 equal to 3. A, B. Clear? Next is what? If I take 3, you will get 4. If you take 4, you get 5. If you take 5, you get 6. Okay? A, B equal to A plus 1. Clear now? Very simple. A equal to 5, then obviously B equal to 5 plus 1, 6. So these are the possible element present in this relation 1, 2, 3, 4, 5. This is a possible relation. So it is said that whether it is a reflexive, symmetric or transitive or not. Let us see. So we can clearly see that it is not reflexive. It is not reflexive because 1, 1, 2, 2, 3, 3 is not present. It's not present. Though 1 is there, but 1, 1 is not there. So we can clearly say that it is not reflexive. So let us firstly prove it is reflexive. Let us prove as a part of reflexive. So as we can see, as 1, 1 is not belong to the relation, but 1 is there. Okay. So it is not reflexive. It is not. I hope it is pretty clear. Very easy. With a very simple way we can prove. Now let us see whether it is transitive or not. Transitive means what? When A, B present, B are present or not. Now you can see there is 1, 2, but 2A is not present. There is 2, 3, 3, 2 is not present. So we can clearly say that it is not a symmetric also. So let us prove a symmetric. We can write as 1, 2 belong to relation, but 2, 1 is not belong to the relation. So we can say, so it is what? It is not symmetric. It is not symmetric. I hope that's definitely that's damn clear. Now let us go on proving the third part, that is your transitive. You can see A, B, B, C, A, C is not there. You get it? A, B, 1, 2, B, C, 2, 3 is present, but 1, 3 is not present here. So we can clearly say that it is not a transitive also. So you can see as as 1 comma 2 belong to the relation comma and 2 comma 3 also belong to the relation, but 1 comma 3 is not belong to the relation, means a comma c is not belong to the relation. So we can clearly say that it is not transitive. Therefore it is not transitive. I hope that is clear, pretty clear, very simple, easy, ekdam fantastic, fatafati. So here goes another question. Actually it is raining here, so the sound might not that clear for you all. I also feel uncomfortable because it is not of rain. So I think after doing we should stop this class now, and we can continue next class, this one. So show that, and you try to solve the next few questions by yourself. It is very easy question. Just understand and go on solving it. So that the relation R in R defined as R is equal to A comma B, where A is less than or equal to B. A is reflexive and transitive but not symmetric. The question is that says that it is reflexive and transitive but not symmetric. Let us go on solving it. So solution. How is the relation defined? Relation is defined as A comma B, where A is less than or equal to B. This is the relation. Okay, and the relation is defined in the real set, real number to real number. I hope that's pretty clear. Real number to real number. So if you take 1, you will get 1, obviously no problem. If you take 2, you will get 2. You get 2 because why? As 1 A and A is possible, because A is, if I take 1, 1 is also equal to 1, right? So it is existing in a definition. So let us prove reflexive. Okay, so we can see here 1 comma 1, 2 comma 2, okay, a 1 comma 1, 2 comma 2, anything comma anything, okay, any x comma any x belong to the relation. This all belong to the relation, as it is already given, as here, as 1 is at least equal to 1, right? It is said that how the condition should satisfy. The condition is given that A should be less or equal to B. So 1 is not less, but at least it is equal, right? So at least one condition is fulfilled. And 2 is less, not less, but equal to 2 at least. That is, I can say here, A is less or equal to A. Okay, for all, this is the symbol for all A belong to the relation. So we can say that we clearly, therefore here we can say that A comma A belong to the relation, so it is reflexive. So this is a reflexive question. Now let us solve for symmetry, transitive. Now anyone you can solve, either symmetric or not. But it is said it is not symmetric. So let us go on proving that also. That is very interesting. It's going to be interesting now. Very easy question. Now here, look here. Symmetric. Let us solve it. Let 1 comma 3 belong to the relation. Obviously 1 is less than 3. Okay, but 3 comma 1 is not belong to the relation. Obviously 3 cannot be less than 1, right, or equal to 1. So we can say clearly that this relation is not symmetric. Therefore it is not symmetric. It is not symmetric. Clear? Very nice. Next is your transitive. it's going to be transitive, because let us consider, for example, very simple, I am going to make you understand very simple way. For example, consider 1, 2 belong to the relation, okay, and 2, 3 is also belonging to relation. Very simple. 1, 2 belong to relation, 2, 3 belong to relation. Also, we can say that 1, 3 also belongs to relation. 1, 3 also belong to relation. It is your own example. Very simple, because 1, 2 belong to relation, because 1 is less than 2. Obviously, it is suited. It is suited in this relation. And 2, 3 is also belong to relation, because 2 is less than 3, definitely. And also then we can take 1, 3 is also in the relation for every real number, okay. So 1, because 1 is definitely less than 3. That means here we can say that A, B belong to relation. Why it is belong to relation? Because A is less than B. Okay. And B, C is also belong to relation, because B is less than C. If A is less than B and B is less than C, definitely now A will be less than C. Then we can clearly say that A, C is also belong to the relation. Is also belong to the relation. Is also belong to the relation, we can say, because A, B, A is also less than C. Simple logic. Therefore, it is transitive. Therefore, it is transitive. I hope that's damn clear, my dear. Very interesting. Thank you. We shall continue next.